formal definition of a limit is actually very confusing. So we're just going to kind of do this definition here. So a function f of x has a limit as x approaches value c if and only if the right-hand limit and left-hand limit both exist and equal the same number. So they both equal the same number from the left and the right side. We've talked about this already. Then the limit f of x as x approaches c is L. So the way we write this symbolically, and recording, yes, we are recording. So the limit as x approaches c of f of x exists if and only if, and this phrase right here sometimes is abbreviated as IFF. Some people do that to make it easier. But the limit as x approaches c, my bad, forgot about the c there. The limit as x approaches c of f of x exists if and only if the limit as x approaches c to the left of f of x and the limit as x approaches c plus of f of x. Remember, this is called the LHL and this is called the RHL. Both exist, so you can find what they are. And equal the same number, which we can call L. L meaning the limit. Then your limit as x approaches c of f of x equals L, whatever number that is. So whatever the LHL and RHL both equal, the limit's also going to equal this. The limit as x approaches c will equal the same thing. So that's what how we define a limit. And we have a question here. Great question. So, so the limit cannot exist in the case that there is not a line coming from one side. Okay, when that happens, actually, we're going to get into that. That's a great question. So if there is no LHL or RHL, you just rely on the one side limit you do have. Yeah, because what if, right, you don't have an LHL, you only have an RHL. You still say the limit exists, but you just use the RHL, that's it. Or let's say you don't have a right hand limit, you have a left hand limit. That's okay, it still exists, just use the left hand limit. So you just use the appropriate one side limit that you do have. But if you have both, you gotta make sure they equal the same number for the limit to exist as x approaches c. If they don't approach the same number, then forget it, the limit does not exist. So let's go through the implications now, because actually that question that was just posed in the private chat is part of these implications here. Okay. Again, I am recording this, so feel free to check out the recording when I post it later today. So some of the implications here. Obviously, the left and right-hand limits are different than the limit as x approaches c of f of x does not exist. Remember, this means shorthand for does not exist, DNE. Yeah, they approach different numbers like we saw in the homework, they don't exist. And we do not care what f of c is. It does not matter at all. So for example, f of c may equal L. Remember, L was the value of our limit. F of c may not equal L. Or f of c may not exist at all. Like you could have had something like this here. And x equals c is not part of the domain. That could happen too. Add the word may, remember. The y value as at x equals c could equal the limit, could not equal the limit, or just not even defined as part of the function. So don't worry about it. So the bottom line is, don't worry about f of c when evaluating limits. It doesn't matter at all. It's all about approach. Any questions so far before I move on to the last implication? Then we'll go to page 3. Nope. Okay. We're going to explore infinity in 2.2. We're not going to talk about much about infinity in 2.1. But remember, your limit is a number. Remember, L is your limit. Has to be a number. Infinity, just so you know, positive or negative infinity is not a number. It's this abstract idea that x keeps, your number just keeps getting larger, right? And there's no end to it. So usually when that happens, we typically say D and E. Because is there a limit? No. Like it's kind of the expression like, hey, the sky is the limit, right? That you can do whatever you want, or or something just keeps going up forever. Yeah, you don't have. I mean, a limit means you stop, right? When there's a limit, you stop somewhere. Let's look at this graph, tangent x, right? This doesn't stop. This goes up forever. This goes down forever. So the limit would not exist. Now, could you say infinity? Sure. You could say infinity, but D and E is fine too. If you said D and E, you would not be wrong. You would be correct if you said D and E, because that's true. The limit does not exist. Sometimes it is good to say infinity or negative infinity. Sometimes it is good to be a little more explicit, especially when we're trying to understand graphically what's happening. And there'll be situations where I'll tell you where I need you to tell me that. But if you said it does not exist, that's fine, because it truly does not for that scenario I just showed you. Okay, any questions so far? Yeah, we got private chats. Let's see, what do we got here? Yes, limit only applies to y. Yes, we're only looking at what y approaches. Right, we're doing the limit of f of x. F of x is y. So we care about what y is approaching as x gets closer to a number. That's always, so like in this case, what is y approaching here? I don't know. It's going up forever. What's y approaching down this way? I don't know either. It just goes down forever. There's no limit. So yes, we are looking at what's happening with y as x approaches a certain number. So let's take a look at page 3 now. And then we're going to do stuff analytically. And we're just going to see how far we get today. And I know we go till 10, that's right. Okay. So let's look at these graphs here. if you graph each of these, you have that. This graph is kind of funky, just so you know. This graph looks like this. The reason it looks like this is not defined. At x equals 0. I think we may have had that in the summer assignment. And if you did a table for b, like if you plug in 1, sure, I get 1. 1 over 1 is 1. If I plug in 2, I get 2. Sorry, I get 1, because 2 over 2 is 1. If I plug in -1 or -2, I get -1 up top, but I have +1 down below. Or if I put -2, I get -2 top, but +2 down below. That ratio is going to be -1 in both cases. And it's a piecewise function because it's not defined at x equals 0, and they're going in the left side and right side of x equals 0 are different, right? Okay, so let's actually do this in breakout rooms because I think you guys need a little bit of a chance to kind of talk to each other. So I'm just gonna have you guys just do A, B, C, D, and E in breakout rooms. I'll give you guys maybe about 3 or 4 minutes to kind of think about it. And then we'll come back and we'll look at answers. And then we'll do the analytical part after that. So again, here's a graph for A, absolute of x. As you guys should know, it's a V-shape. We've done it many times since Algebra 2. B, I showed you this graph is a piecewise function. So there is a break at x equals 0. So hopefully you have those graphs drawn correctly on your notes. And you guys can do A, B, C, D, and E. So let me go and clear. Stop sharing. Stop the recording.